welcome back. I think this is March 25th. We're finishing the second part of 7.4B. And again, when I'm checking homework, I'm not grading it. It's just a method for the school to see that you're doing it so that you're gainfully employed while you're out of school. In 7.2, we learned when we were going to rewrite a rational function to see where its asymptotes were, what its characteristics are. We did that by long division. So we took that denominator, that was the divisor, into the quotient, and we divided, we saw a remainder, and we rewrote it with the remainder 2 over x plus 1, plus that whole number quotient, which was 3. Looking at this form, easy to see that the vertical asymptote happened at that excluded value when x was -1, and a horizontal asymptote happened at that constant term. Notice that you get the same thing. If I look at here, the excluded value, that's always the vertical asymptote, and this 3 over 1 was how we could look at this without rewriting to see what the horizontal asymptote was. In example 5, there's still another way to rewrite to see what they are, to put it back in this sort of standard form. They call it inspection. And the idea is I want to rearrange this numerator in such a way that I can cancel this denominator. And so the thinking is 5 could be written as 3 plus 2. And I can separate them and put them over a common denominator. So 3x plus 3 over x plus 1 plus 2 over x plus 1 has the same value as I started with. The benefit when I factor out that 3, which is why we did it 3 and 2, is that now I have it in a standard form, sometimes easier to see what's going on. 2 over x plus 1 plus the 3. So you can see that we have exactly the same thing. I don't know which way you think is easier, and I don't know that it really matters which way you get there. It's just another tool for your toolkit, as we say. Another example, suppose I have 5x plus 13 over x plus 2. I want to be able to cancel that x plus 2, and I've got 13 up here to work with, so I'm thinking 10 and 3. So 5x plus 10 plus 3 all over x plus 2, and I'm pulling them apart, writing them as two fractions, so it's easy to see that when I factor, I can cancel part of it, and this one stays as the remainder, and so I end up with 3 over x plus 2 plus 5. A horizontal asymptote when y equals 5, and a vertical asymptote when x is -2. Look at monitoring progress down at the bottom of page 386 and rewrite the one they gave you. You could be doing that while I'm doing this if you don't pause. And then check and see what you got. You started with 2x minus 4. Is that what it was? Yes, it was. That cancels, and I'm left with 2 over x minus 3 plus 2 as my final equation. That was monitoring progress. That was the easy one. Now we want to look at complex fractions. That's the second part of this lesson. Complex fraction is just a fraction that has a fraction in its numerator and a fraction in its denominator. In the simplest form, that was a over b divided by, not necessarily b, c over d. The first fraction stayed the same, so a over b. This division bar changed to multiplication, and that bottom fraction flipped. So we multiplied by the reciprocal, and you ended up with a times d over b times c. There are two methods to doing this. One is I call it a traditional method. I think your book calls it method 1, and it's probably what you are most familiar with. And so I'm going to start with that one. But method 2 might be easier in the long run. So look at the first example, which was 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. In the traditional way, we're going to write the numerator over a common denominator. We write the fractions in the denominator over a common denominator, and then we'll flip and multiply. So that numerator, lucky for us, is already over a common denominator, so we don't have to worry with that. This one needs a common denominator, and it's going to be x times x plus 4. This one has the x plus 4, it just needs the x, so I'm going to multiply this by x. This one has the x, but it needs the x plus 4, so that numerator part gets multiplied by x plus 4. And when we finish and we multiply, I'm going to end up with x plus 2x plus 8, and I'm going to go ahead and combine those terms, so I'm going to have 3x plus 8, all over this new common denominator, x times x plus 4. Numerators over a common denominator, the denominator fractions over a common denominator, time to flip and see where we have. So I've got 5 over x plus 4, times, flip that one, x times x plus 4, all over 3x plus 8. When you are doing this, notice where you have to look for excluded values. This denominator, this denominator, this denominator, and this numerator. Because so this denominator and these numerator and denominator. Because any of those, I can't even get this far if this one if x was 0 or negative 4. When I flip, this cancels, and I'm left with the final answer of 5x over 3x plus 8. Again, those x's don't cancel, because down here I have a plus sign. It's like a big stop sign for canceling. So that was method 1. And I'm going to leave an answer up there so we can make sure we got there. 5x over 3x plus 8. Method 2 starts with the same fraction, same idea, but instead of writing each one over a common denominator, the numerator over, I'm going to multiply the numerator and the denominator by the LCM for all the fractions. So in this case, it's going to be x plus 4 times x. So this numerator gets multiplied by x plus 4 times x, and that denominator gets multiplied by x times x plus 4, and see what happens. So when I'm multiplying that numerator, this cancels, and I'm left with 5x. In this denominator, the x plus 4 cancels, so I have x plus, over here I'm multiplying by x plus 4, the x's will cancel, and I'll have 2 times x plus 4, which is going to be 2x plus 8. When I add those like terms together, I have 3x plus 8. Fewer steps. It feels weird at first when you do it, but I think if you stick with it, you will like it better than the traditional method. For the first 10, 11, and 12, I would like you to do those both ways, just to practice. And then tonight's homework is, no word problem. So tonight's homework is going to be section, the exercises 7.4b, worksheets 1 and 2. You can pick whichever method you want to use for those. I think I did the handwritten one using the traditional method, but I really recommend that you do them the other way. I think you'd like it better. And then tomorrow, no video, thank goodness for me, but you'll have textbook problems 1 and 2, 4 through 42 even, 45, 49, 50, 55, 58 through 62. I heard a noise and it's late at night, and we were here. So pause, go look at 10, 11, and 12. See which both ways, and I will put up the answers while you are doing that. For number 10, no matter which, for both ways, I should see negative 5x over 3 times 2x minus 7. Number 11, should have gotten 2 minus 4x over 2 plus 3x. with 3 times x minus 3, or you can multiply this together, it doesn't matter, over 3x plus 7. As long as you know those 3 x's don't cancel, these x's don't cancel, those 2's don't cancel, because they've got those plus signs. This finishes 7.4b, and the homework we've already gone over. Remember to keep a paper copy of the homework that you upload for me, just in case, and we'll go over it when we're back together. And I will see you